Today we will discuss the subject in brief, EC407 in nutshell. The objective is to provide you idea what is the key essence of the subject. So whatever we covered in the past 5 months classes, we'll try to compress it within 1 hour and try to give you a roadmap as to how to study. For more detailed content, I've already uploaded the videos to this YouTube. You can use those links, see it, and read the things from there. But this will be a brief intro about brief summary about what happens in this subject. What's the key essence of the subject? So hopefully this will help you for the exams as well. So you are aware of this data communications. What is the difference between data and information? Data is just raw facts. The information is processed data. So data is getting value when it is processed and it becomes information. That's what information technology. The components of data communication. You have message, sender, message, then channel. All those are the components. Receiver. There will be protocol. So protocols are what we discuss in the large portion of the subjects. We discuss say 2 dominant protocols. We always hear about Tcp Ip. Then there are support protocols for each of these things. So protocols basically a set of rules for 2 parties to communicate. So it might be between peers, it might be between 2 layers, 2 entities. So different types of protocols we come across. We have discussed most of them except POP in our classes. Then the direction of communication, you are aware, simplex, duplex, all those things, full duplex, half duplex. So this network security we will deal in the last module. Reliability, all those things are discussed there. Until the 4th module, we will be discussing a lot of things about the network itself. So different types of communication, point to point, the topology, star, bus, ring, a mesh, all those things are aware. Just ring topology. We won't go into detail about personal area, body area network is something. This is about the NK and everything. Just leave those things. We have mentioned autonomous systems. We will come to those autonomous systems later. Autonomous systems rankings and all will discuss what is an autonomous system later on in the lecture. We'll see that. So internet. So this is how the internet looks when say in 2016, I think it's picture in 2016. They try to measure the packet length, the distance to different points. So how it's going in an enormous rate. So the textbooks, the Feruzan text is the book with week 4. So you'll find otherwise Kuros. That is also a good text. So data transmission mechanisms. This comes in the first module part, all those things. There are 3 ways, 3 more, serial and parallel. Serial itself, you have asynchronous, synchronous, and also isochronous. So this is the serial transmission. So data, so parallel transmission. So you have where data is sent over parallel lines. You call them as a bus. Serial, you have it goes in a stream. So if you check your motherboard, you have SATA and PATA cables. SATA is parallel, the old ones. The serial cables are this serial tapping. Serial cables are also existing. So now there is there is a format. So it could be asynchronous or synchronous. Synchronous is always synchronized to your clock, whereas asynchronous don't have any synchronization, but they will have start and stop bits to do the synchronization. It is say where standards like ATM, asynchronous transfer mode in the earlier days of data communication. Those didn't really pick up. So isochronous will include features of both synchronous and asynchronous. So leave all those things when we come to switching. Two dominant concepts there are circuit switching and packet switching. So we are now talking about data communication networks which have packet switch networks. We have efforts to have a switched concept in IP layer, but that does exist to some extent. So MPLS, multi-protocol layer switching, that is a topic which we do in I think third or fourth module. Multi-protocol layer switching. I have given a PDF of the MPLS. You can do it. So you have circuit switched, packet switched, and message switched networks. So these concepts. So circuit switch involves establishing a physical path between the source and the destination. So it involves the three phases: establishment, the data transfer, and the connection is terminal. So three phases of it. It's very reliable, but it's not a very good use of bandwidth or resources because the connection has to be maintained throughout the duration of communication. Now, even if there is no data to transfer, still the channel is that connection is maintained. So that is not a very there is case of delay also. Initial part, but once you have established a connection, it's fully available throughout the duration. That's there. Whereas packet switch networks, on the other hand, the message, say you will divide in packets of variable side, it's not a fixed type, some could have. So it will travel different paths and it will reach its destination. There are two types of packet switch networks. So, and the packet switch, the destination, the packets reach the destination through different paths. So you will have to ensure that somewhere there is some arrangement made the destination set. There is a sequence to be made. So we see later that the TCP does those things. TCP gives you out of order sequence, you will see some packets. It is this TCP ensures that it is rearranged. So the packets are numbered say from 1 to 10. And you first get the fifth packet, then the first packet, then the fourth packet. The TCP transmission control protocol will ensure that it is rearranged. Usually on the other hand, does not transmission times. We see later down the line. So that's regarding circuit switching and packet. Datagram networks and virtual circuits. So we mentioned that there are two types of packet switch networks: datagram networks and virtual circuit networks. You go through this topic later. We won't spend time on this datagram and virtual circuit. You can read through it. It's quite an easy topic to it. So, okay. So packet switching advantages and disadvantages. So there is better utilization of resources, bandwidth, and also it's much more redundant, robust. There is a failure, there is an alternate rerouting of paths. That such things are possible. So that is redirection into all those things are possible. But it has also disadvantages. The delay, packet to packet delay varies. Different packets experience different types of delays. So that's there. Then there is the case of packets getting corrupted, lost. So if you really require retransmissions, you will have to ensure that those things are say depending upon your need, what type of application is using this network. Based on that, you can develop a packet system. You can give different various features to the packet switch network. So message switching is a sort of store and forward. Read the full message at each node, store it briefly, and then forward. Yes. So this the classic example of this is your email. Email is stored in email servers. You are sending an email, say your Gmail service. So it goes from your mobile or your say computer to the mail server, and there is through a particular protocol called as SMTP, Single Mail Transfer Protocol, and then it will go across Diverse networks, heterogeneous networks, and randomly reach the destination server, and then it is accessed by your client. Like say some other protocols, TCP. So message switching is happening in the application layer. But within this internet, what is shown as cloud is following the packets. So taking different path. So, but when you store the server, when you log into your account, you are actually accessing your main server there in the JIM, your folder there in the JIM. So that's message switch network. So this is the summary of this. Then physical media, I don't think we need to take much talks. Three, there is guided and unguided, broadly. So sender, receiver, so guided and unguided. Guided involves media, fiber, coaxial, copper wire, all those things. Unguided, basics, light, all those things. So light can be transmitted without a media also. That's possible. Short distance communication is possible. So this is twisted pair, all those things. You can read about those things. Okay. So network models. That's what the one particular key thing is. We need protocols. And why do we need protocols? Because we are going to have interaction with different entities, application entities. Now, when you have such a thing, there is also a case of layer. Why don't we have a single solution for the whole thing? But much more flexible one is to divide each functionality into different layers, because that will create a modularity. We'll be able to reuse functions. We'll be able to isolate changes in one layer, one other. Change the technologies within the layer. Everything you need to clearly specify the interfaces. Interfaces won't change. So, for instance, this layer should deliver 500 to the other layer. It's clearly specified. You need to know about what happens in the layer 1. Just give it 500 out. And this layer is going to give you 3.3 more out. You need to know how it is done. Changing the technology. So that's possible. So the interfaces are clearly specified. So that's what the layered protocols. So we discussed about this thing. You see the video how we mentioned this thing about the steps, all those things. Advantages of the layered protocols. What have we mentioned now is summarized here. So this is an analog involved in picking up a letter and all those things. Peers, terminologies, there are peers. Peers are entities the same level. So peers. So for instance, layer 2 and layer 2 on both ends are peers. Peers, same level. So there is a logical connection between these layers. Maybe we'll see later that when we discuss the physical layer is only directly connected. That's physical connection. Physical layer connection is there. But other layers communicate using logical connection. Logical connection. Because they have some bits or fields which are understood by the other layer, other side. Sender will, whatever the sender has to communicate with the other side, will give us some. You will have some bits in the headers or rails. So when it reaches the other end, the receiver side, the receiver layer will understand that. That's how this logical connection is made. Other layers will ignore those things. Only the particular layers. Three layers will send message to the communicate something to the layer 3 in the receiver side. It will communicate using some bits in the headers or rails. Data being sent. So that information is understood there by the layer 3 receivers. That's what we call the logical connection. They don't have a physical connection. So that goes. Again, there are two dominant layer network models. We discussed those things: open system interconnect and TCP. We will discuss much about OSI model. We will discuss about TCP Ip model. So again, we come to this. It's not a protocol. OSI model is not a protocol, rather it's a reference model. It's a reference model for developers to what do you say, follow. That's what. And we discuss about the politics involved in the OSI. So 7-layer protocols and application, presentation session, transport, internet, and physical layer. So we won't discuss each of these functionalities of these layers, but we mention 2 or 3 concepts. So if you see here, there is a peer-to-peer, what do you say, logical connection. That's physical connection with the product. That is the physical connection. That is somebody, the 2 physical layers are interconnected. There are also intermediates, which are called later on as routers. Intermediate nodes, so you don't have direct connectivity to any other node. Maybe it is a distant node, so be an intermediate nodes. So these intermediate nodes will be called routers. Routers will operate at the lowermost 3 layers. Concept. Okay. Was the layer says that it operates in the routers. The routers has to follow this thing. So it needs to know the address. So it needs to access the network layer command. You will go beyond that. Usually it will go beyond it. So that's what you consider the 2 things. Then again, we go to this concepts encapsulation and decapsulation. For things, so if you mentioned, you will have header information with this decapsulated progress and others by the peer layer. So encapsulation process and the decapsulation process. Right. So again, this physical layer functions, all those things you read up. Data link layer, the main key functions are framing, physical addressing. Physical addressing for this packet address. All the way to the packet. The phone has packet. Bluetooth auto has a separate packet. Separate address. You integrate your phone Bluetooth address. This is separate address. So this data link layer, physical addressing, flow control and error control. Flow control and error control is functions which are run in the data link layer to some extent, but much more higher than the transport. When we discuss Tcp Ip model, the transport layer, which is purely mostly concerned with this flow control and error control. So again, I want you to check up these things. That is switch, bridge, what are the difference between a switch, bridge, and all those things we mentioned in the class. So data link, basically you can say that data link is concerned with a good example of Ethernet is a good example. This operating at the data link layer. Connects, you can see. So this is a hop-to-hop delivery. Then network layer, you call it as packets. The network layer, the main functions are logical address. That is where you have IP address. And then you have routing. Also, so these are the 2 main functions. You have logical address and routing. Routers route using different routing algorithms, routing protocols, routing algorithms, which we discussed later. Okay, coming down the line, we have to discuss those things also. So, okay, we have covered 1/4 of the slides. So that's transport layer. Transport layer is end-to-end delivery of the entire message. So let's not say transport layer has to deliver this message from say sender to the receiver, to the correct process, application layer process. You will see that application layer process and the transport layer communicate using port numbers. Port numbers, we discussed about port numbers. So this anyway, this OSI is just a reference. So this that is what you call as a service point addressing. We call it as service point addressing. So we discuss about service point address. Okay. So segmentation, reassembly, all those things. So again, there is two important concepts. That's service and connection. So connection limited service is something which is similar to your circuit switch. Connectionless service does not involve establishing a connection or sending the data direct down. It just sends the data, a packet switch network, just like packet switch goes, reaches the destination. You may lose packets or packets may get corrupted. If your protocol needs the lost packets to be retransmitted, transmitted it into the mechanics. It's lossless loss. Comparatively, TCP and UDP lost packets are lost. So, live stream, you lose a portion of this loss. Doesn't it? It's not. UDP is UDP and variance when you stream your live streams. So, that is lost. However, TCP will try to get a transfer. This I have received this. There are different ways to do this. I can send the entire thing from where you lost, say you lost a quick packet, now you are 10 packets, so 5 to 10. That is an or it's just a lost packet. That comes the sliding the protocols. Go back and we discuss those things there. Okay. So we discussing the data link layer, but the concepts are there in the transport layer as well. Session layer and all those things. The OSI people also were confused what to do with these functionalities. There was a lot of politics involved in this. Okay, and finally the human interaction is with the application layer. So follow those things. So this is your TCP model. TCP model. There are technically there are 3 layers only. The lower layer, the data link and physical layer, as we have in the OSI model. That's not personally part of the TCP Ip Model, but it's below there. Upper layer network transfer application. These 3 layers are clearly different. Very different. So again, we have an encapsulation because we are sending whatever appears are communicating using bits in the headers. Headers also sometimes there are trailers. We will see in the IP layer that there are trailers also with packets. Packets will have header as well. So the link layer is the data link layer. Where you have the different the protocols, internet. Primarily, all those things comes there. In internet layer, we have the dominant protocol that is IPv4, IPv6. IP support protocols exist. ARP, all those things, address resolution protocol, all those things. Again, the TCP transfer layer, there are 2 dominant protocols: TCP, UDP, and SCP. That is also there. Then application layers what you interact. So HTTP, all those are application layer protocols, file transfer protocols. So there is a comparison between these two. So the difference between IPv4 and IPv6, that's also there. So let's move on. So these are the various applications, say your application layer protocols. It's a comparison between the OSI and the internet layer, internet protocol. So as such, it is IP layer is the beginning, then transfer and application. Lower layer is it's not a botheration of internet TCP/IP protocol because IP is a protocol. Internet protocol can go over diverse networks because IP, the logical address is unique. It's unique. It can go over diverse networks. So that's in 2015, right? So this is a brief intro about internet protocol, but we'll just skip through it. It's not really relevant to the discussion right now. So one thing is data link layer. So we are on the data link layer. We'll define what are some things. Say one thing is a node, and each of these ones is a node. Could be a machine, could be anything. It's defined as node. You are say it's so how the communication happens. So here it is shown as you see here two communication entities. They are communicating. So the data layer is communicating between across diverse networks. Intermediate you have. So your data will go all the way to the network layer. Shown here as till the data layer. So data link layer, the data unit is called as a frame. Frame. The physical layer is called as a bit. Zeros and ones. Zeros and ones. Let me also much faster. So are able to transfer. Do you want me to go like this or just take any other problem? Yes or no? So so this is the data link layer. The unit is called frame, and they are in so header and trailer. We discuss those things. There are two sublayers. One is called sublayers, and it comes back sublayer, and also control sublayer. So MAC sublayer we discuss MAC protocols. So and again medium access control. Medium access control. In medium access control means basically say you say that the channel is a shared medium. Shared medium, whether it is Ethernet cable or whether it is an unguided space, a shared space. Different people are trying to communicate. All these people are trying to do at the same time. Who will communicate first? Shared medium access. That is what medium access control. So medium access control, there is function and then now this concept is what we have. This is Aloha. This is Aloha protocol. We discuss about persistent programs. One persistent, three persistent, two is going to access. Say for instance, two people somebody must be trying to ask a doubt to me. So one person will have to back off. Back off में running this Ethernet. Persistent. So one of them will be back off. And then it tries to be. That's what we call the persistent server. So medium access control. So that exists for all shared media. All shared media. So max layer discriminates the channel access. Then there is a flow control and error control. Flow control, the signal is not drawn slow receive. That's why I asked if it is drawn the receive with the data, the sender might be having a high throughput, whereas the receiver might not be having enough of buffers, buffer the data. So That's the basic premise of programming. We saw in TCP how it is done. Framing. Okay, so framing the bit-oriented character and all those things, then can read through this. This is a concept which we are as and all here they are shown. They have physical address. Okay, and there is intermediate nodes also have different physical address. Rulers also have physical address. From the ruler, you see here address. This is the ruler, this is the ruler. Each of these is a L2, L2. Incoming and outgoing have different physical address as well as link addresses. Link addresses as well as IP addresses. Here we have several input lines and several output lines. So, which output line the data has to be sent determined by within the order. As well as the direction which is is sent. So, this is the source and the destination address. IP address will not change. The destination source is Alex IP address and destination is Bob's IP address. So it goes across different networks. Each hop, its link address will change. Link address will change. But the destination source addresses will not change. Because that has to be fixed. Address leave those things. Low-level protocols, you have simplex, overlapping, sliding window, selected to each. So this is there is a separate video which has been put there. Go through this, the flow control, because otherwise you won't be able to discuss. So basic idea is that the fast sender should not drown the slow receiver. There should be some sort of communication. Simplex protocol does not have any flow control. The sender will keep on sending data. Stop and wait. Send some data. Wait for an acknowledgement. Okay. The receiver will send an acknowledgement. Stop and wait. So there is also a case of timer. Okay. So we discussed how this is accounted, lost packets, frames, or all these things accounted in this stop and wait protocol. Okay, remaining things I suggest you check up the lecture videos on our YouTube playlist. There is a case of error control. Error control, different strategies are there, error detection and error correction codes. The context we discussed about CRC. We have a problem of example. Let's see. Yeah. So, error control, error detection and error correction codes. Okay. So basically, it's a redundant elements, redundant bits are added. Redundant bits are added to ensure that your data is some way to cross whether it is correct or not. These are in broadly this the category of error detection and error correction schemes. Medium access control, these are, you see the lectures on medium access control, say Aloha, CSMA, all those things are random access. We discussed CSMA and CSMA field. We discussed CSMA CA. CSMA CA has to do with the wireless. You have to read about it. Wireless protocols differ a lot of ways compared with the wired protocols. So CSMA CA collision avoidance, otherwise collision detect. Because wireless medium do not have any mechanism to detect a collision because the medium is unguided. Whereas collision detection is possible on a shared medium like Ethernet. First, can report for any what is it? Collisions. So this is how this is done in the context of Ethernet. Also, we discussed. So go through this. We have discussed this persistence protocols, all those things there. The lectures are there. Go through it, please. That will be the better option. Ethernet. Ethernet. The earlier days of Ethernet had CSMA CD. Now the this carrying its micromatrix. The protocol is no longer used because we have 6 Ethernet. And so that way ensure that you don't have collisions. You are isolating the collisions. So we discuss those concepts. Collision zones are handled in different protocols, different versions of the Ethernet, right? So Ethernet actually evolved, and we have 10 Gbps, 1 Gbps, gigabit Ethernet is common, 10 gigabit is also coming up. So 10 gigabit is purely optic fiber based. Okay, read this connection oriented services. So one key thing is you should be aware of three concepts. One is circuit switching, another one is connection oriented service, connection led service. Each four concepts are subject. Oriented by layer protocols. Why do we need layer? What is this concept of logical connection? Logical connection. What is the meaning of the logical connection? And how this logical connection takes place? Layers. That's how we have this protocol bits added in the headers. Take one concepts alone. From the lectures will not recognition service. Again, so we won't discuss Ethernet and spend a lot of time. You just go through this topic, the cabling, all those things. We have a separate lectures there in the channel. Go through it. So switched Ethernet is avoiding the chance for collision. Collision probability is much reduced. The switch will be redirected in the particular direction of the particular host. Earlier, hub is a down thing. It doesn't have any intelligence to direct the traffic to the particular host present here. Hub doesn't have any intelligence. Hub is just a hardware that we can just whatever traffic comes, it will send out all the outgoing lines other than the one key. That's a hub. Whatever switch will send it to the particular direction of the particular device. You have to be able to check the address. Check the address, the local address, whatever. And the India address. Send it to the host. That's awesome. So this is the collision zone, all those things. Why CSMA CD is not required in switched Ethernet. Okay. Full duplex Ethernet, all those things will just. So we come to IP layer, network layer addressing. Addressing, we discuss quite a lot of things in addressing. In this section, I want you to take a look at how IP addresses are allocated. IP address allocation. Blocks are allocated. How it is allocated to different users. That's all over to our say. So we discussed about subnets. We discussed two concepts. One is classful addressing, classful addressing. We started with classful addressing, then we went to CIDR. Classful is the domain of CIDR. Right. So these two key figures. Okay. These are the inventors. So we are in layer 3, you can say, OSI model layer 3 or layer TCP layer 1. It doesn't take much time now. So we are halfway through. Right. So, and first thing is packetizing. Packets of fixed or variable size. Fixed size or variable size. That's possible. So, whatever data is coming from the transport layer, the network layer has to divide into packets. Two approaches, datagram approaches. We already discuss some things. Routing and forwarding is also down. So, we discussed three routing methods. That is distance vector, path vector, and JIM-CET. And routing protocols, we discussed two intra-domain protocols, one inter-domain protocol. Okay. So, address space, all those things, the number of bits, we are short of addresses now, especially because of Internet of Things devices. We'll wind up in 15 minutes. We don't wind up. And I understand. So we'll wind up in 15 minutes. That's it. It's now 5 minutes for 2 o'clock. We will complete within 2:15. That will take. That will be enough. So you specified of slash notation. We discussed about slash notation. Okay. This is the classful addressing. Classful addressing had its drawbacks. So the concepts here are classful addressing and classless addressing. Do read about those things and also listen from the video lecture what is the difference between classful addressing and classless. Basically, the initial basic of the internet, they never thought that it should be having this such explosive growth. So they thought they thought that only big companies, big organizations would move to internet. So they are not able to address this, but they are listing the drawbacks, and finally we have CID, class introduction. So those concepts, so classless everything is help to solve the address space issues to some extent. Again, we ran short of we have IPv6, say that peer-to-peer interface to last for several weeks, several days. It's possible. So it depends how we are going to use the internet. So different classes, all those things you just read. Classless addressing, slash notation, mask. In a separate lecture, we problem video problem video slides So you'll have a prefix also. Prefix length specific /24/8 prefix plus whatever. So the fixed portion. So we will not discuss much about this thing here. You see the video there. Number allocation and all those things are responsibilities of organizations, registries, internet registries. So we come under Asia Pacific, ethnic. Okay. This is what we discuss the problems, IP block address allocation and subnetting. Subnetting the problem around subnetting. Simple. Examine ചോദിച്ചാൽ എല്ലാവരും ഇരുന്ന് എഴുതിയാണ് ഞാൻ നോക്കിയായിരുന്നു. അപ്പൊ എല്ലാവരും എഴുതിയാണ്. അപ്പൊ അത് തിരുകൂടി അതൊരു സിമ്പിൾ ആയിട്ടുള്ള പ്രോബ്ലം ചോദിച്ചത് യൂണിഫോം അലൊക്കേഷൻ ആണ്. ഫിക്സ്ഡ് സൈസ് വേരിയബിൾ സൈസസിൽ വരുമ്പോൾ അന്ന് ശ്രദ്ധിക്കണം. പ്രോബ്ലം ചെയ്തേക്കുന്നത് നോക്കണം. സോ അഡ്രസ് അഗ്രിഗേഷൻ മീൻസ് for outside world, rest of your IP public IP address, I have to distribute to the other portion of the we'll see, say, proceeds like this. Say all addresses originating from address that belongs to this particular process, say geo. As we don't do geo. What do you say? Delivery impact first, connect first. So that's address aggregation. So they say all values from the destination address within this address, this IP address, are mapped to this particular place. So that will make the routing tables much more simple. That's address aggregation, route aggregation. Again, there could be a discussion about CIDR special addresses. CIDR special addresses, local hosts, addresses, short ones together. CIDR special addresses, standard special addresses, private IP addresses. Router 192.168. Special addresses. So that's regarding this the network address translation. We have mentioned in the video. You listen to that. What is it? The router is making your IP address is not visible. If you want to know your IP address, say you are actually your host. If we have a router, the router is going to assign your private IP address. Say 192.168. If the router will be having an address, it will be visible to the rest of them. Router will be having an address. So here it is shown here. Say this is this is an IP address which is visible to the rest of them. Here there's a private IP address 172.268. So we mentioned that in the class. So please see that. IPv4 datagram, we won't discuss the packet structure, all those things. Leave that. Routing. So routing is going to decide what the outgoing line to take, and also routing is based on different parameters. Say there could be a case like static routing. Always the packets will follow the same one. Other cases in dynamic routing. Packets will take path different based on network parameters, condition, or policies determined by that. That dynamic the packets will be. That's also possible. So types of these are leave it. So this is these two concepts. What's the difference between the routing and forwarding? Forwarding much of brainwork is forwards, it's off. The post office letter of the model. Whereas routing, it has to make decisions based on various parameters. So routing algorithms do this task. Now, there is a concept called as autonomous systems. This is within the pattern under Insular. So this is autonomous system. For instance, the BSL can be regarded as autonomous system. The Linux can be this considered as autonomous system. Within this autonomous system, we have private autonomous systems. But for the rest of the different, only this larger autonomous system will be useful. There will be a register of autonomous systems. You have private autonomous systems. Each of these autonomous systems will be having an ASN number, autonomous system number. And these autonomous systems, they communicate using specific protocol which is called as border gateway protocol, BGP, border gateway protocol. And inside the autonomous system, there are some internal routing protocols. So that is what we call as OSFP, open source, pathways, all those things are internal routing protocols. So intra-autonomous system and inter-autonomous system routing protocols. Two types of routing protocols exist. So the peering relation, transit relation we mentioned. So routing algorithms, you can say there are two things. Say intra-domain, that is within the autonomous system, and intra-domain means between autonomous systems. So the intra-domain, you have link state, distance vector, and example for this is the routing information protocol RIP, and open shortest path first link state routing, and path vector routing is BGP. Now, during the algorithm, SAL what are the examples? ഒരു എക്സാമ്പിൾ എടുത്തിട്ട് എക്സ്പ്ലെയിൻ ചെയ്യാം. അതുപോലെ ഒരു ചോദ്യം നടത്തുന്നുണ്ട്. അതുപോലെ ചോദിക്കാം, സ്കിപ്പ് ചെയ്ത് ടോപ്പിക്സ്. I understand this is a very elaborate syllabus, very extensive syllabus. There is no other option for this. So we have included the distance vector routing, all those things in the video. Just have a look at this. Videos are I don't think we need to spend more time. We can explain this thing in detail. If you need an explanation further, do ask me. We have an online session. Have a look at those things. That is two node instability, reverse poisoning. അതെല്ലാം ഇപ്പൊ എഴുതിയാണ്, പരീക്ഷ എഴുതിയാണ്, എല്ലാവരും എഴുതിയൊക്കെ വെച്ചിട്ടുണ്ട്. എഴുതിയെന്ന് എനിക്കറിയില്ല. People have written. I checked quite a few papers. So nearly 25% of the papers I checked. So I thought everyone is knowing the subject. So link state routing. Also see the lecture. We just push off from here. Plus routing protocols. Routing protocols. Routing protocols. Routing information protocols. And the third one is border routing. What the idea here is that autonomous system numbers. Okay. So all these three depend on three different routing algorithms. RIP comes from distance vector. That is various. Shortest path first uses link state patterns. Link state database link state. Border gateway protocol is much more elaborate thing. So, and again, we discussed initially that just about multi-protocol layer switching. So, implement a protocol with a connectionless protocol. Because each of these packets will be having the IP address. Whenever the message will packets are, each of these packets will have the IP address, destination as well as source IP address. The packets പല വഴിക്കാണ് ഡെസ്റ്റിനേഷൻ എത്തുന്നത്. കണക്ഷൻ പ്രോട്ടോകോൾ അല്ല, കണക്ഷൻലെസ് സർവീസ് ആണ്. But there were efforts to create connection oriented chapter to the protocol. That resulted in something called MPLS, multi-protocol based. So, creating so to give a connection oriented character to the IP. That is the approach done in MPLS, multi-protocol based. So we will go in depth about each of these algorithms because they have been put there. Do read about it. Do go through all these border gateway, all those things. We are in transport layer. So transport layer, the key concept is transport layer in the receiving the services of giving the message to the network layer, which is packetized by the network layer and sent to the layer down below, data layer. Now, transport layer is one layer. Transport layer has to deliver the message to the correct process running the application. It is a web browser. Does deliver this data to the correct process. And it does the thing by setting up a path by using service point address. We call this port addresses. Application layer programs and processes and the transport layer will complete port addresses. Port addresses. So encapsulation, decapsulation, all those things, it exists. So this is the concept there. Process to process communication is a logical connection. Logical connection. So your internet layer will be able to deliver from one host to the other. But it is the responsibility of the transfer layer to deliver to the correct application code. Application layer process. Software or service is updating. Web browser FTP service process. Responsibility transfer. End to end. Other sources. Port addresses, service point address, you read about that. Well-known port addresses ne kurichu padikane. Port addresses ne kurichu just a short notes. Port number ranges, all those things. Socket address is a combination of this IP address and the port number. Do read about these things. Okay. Again, this concept connection or interconnection. Again, knowledge concepts are clear. Connection with different connection with service. There, of course, how we can increase communication. There are many something approach and something to read. So, connection oriented services വായിക്കണം. അത് നമ്മൾ പറഞ്ഞിട്ടുണ്ട്, ക്ലിയർ ആയിട്ട് തന്നെ ഡിഫൈൻ ചെയ്തിട്ടുണ്ട് കാര്യങ്ങളെല്ലാം. So this flow control and error control happens at a higher level in the transport layer. Data link layer നടക്കുന്നു. It's done in the transport layer as well. We discussed about TCP as well as UDP, two protocols of the transport layer. TCP നമ്മൾ discuss the stream oriented protocol. It's a connection oriented protocol. Connection oriented protocol. IP layer is connectionless. The layer above transport layer has a protocol which is connection oriented. So the transport layer for transmission protocol basically it is a connection oriented protocol. It's going to use the services of the connectionless IP layer to deliver a packet to deliver a message to the destination. So, the connection oriented transfer layer should have other than work during transmissions. This is forming part of the operating system. Whether it's Windows or Linux, basically operating systems are part of the operating system. You are not installing PCB condition. You are part of the operating system. So again, well-known port numbers. There are 4 port numbers in it. Okay, 4 port numbers in it. At least HTTP, HTTPS, all those things. Okay, then flow control, error control, all those things you can. This is number TCP numbering detail discuss how these packets flow, how these three-way handshake. This three-way handshake. Three-way handshake connection whereas they have logical connections where three-way handshake. So that is what is discussed in this subsequent sections. So the sender side and the server side, client and client server model, they should have logical connection. Three-way connection. Videos where we have mentioned that details about this. Okay. How the data transfer takes place and how the connection is terminated. That is also there. That also we are discussing it. When compared to this TCP, there is a UDP. This feature is really worthwhile. This is really this is compared with packets are lost. The PCB will call the sender. Then this packet is lost in sender packet. We have already buffered this sender packet. So we will put it in the correct order and deliver it to the correct service. Application service, whether it is TCP, STP, STP. Whereas UDP, packets lost, no moderation. Process lost. So he is much more comfortable working with that. It's a connection oriented service. It's a connection service. UDP is a connection service. So these are doesn't mean that UDP is bad. UDP has different applications. Depending on the application you choose. We mentioned about all these things. The Wireshark, you can do a packet capture session, all those things. Then the transport layer. Functions. So UDP, discuss about UDP, checksum, the pseudo header, and all those things. So the comparison between TCP and UDP. To read about this thing, and we summarize the points, and you need to know what the TCP comes to say.
You know the key concepts. So then it's the same discussion follows up to UDP and then UDP flood attack, then DNS. So the domain name system is a sort of directory of the internet, and how the DNS is implemented. DNS is implemented as what do you say, hierarchy. Hierarchy. It's implemented as a hierarchical way. How it is done. How the domain name space is created. There could be subdomains also. Subdomains within the each domain that's possible. This is how let's say the domain always ends in a root. That is a that is eating out, basic out. So it's in a dot. So it's there are top level domains, country level domains, PLEs, top level domains. So that is the country level, generic domains. Generic. There are country level, all these are country level domains. That's right. So what are this? Then how the domain name system works. We studying about how the name servers, hierarchy of name servers, primary and secondary servers. Two concepts here is how the DNS works. Because how this domain name resolution and iterative resolution. These two concepts. Recursive and iterative resolutions. Okay. And we discussed about this person. It's a very simple person who used to do these things. John Postal. Okay, John Postal. So that's it. So